Welcome to this explainer. You know, if you've ever looked at a massive tech platform and felt completely overwhelmed, wondering how it all actually works behind the scenes, you are absolutely in the right place. Today, we're unpacking something super exciting. We're breaking down an incredibly generous 10-plus hour masterclass blueprint created by Singh and Mukihi. It's basically a complete ground-up guide to building a production-ready backend architecture. Right off the bat, let's start with a really bold claim. Sangam throws down an open challenge at the very beginning of his curriculum, and it's this. High-quality, practical system design education absolutely shouldn't be locked behind some expensive paywall. He literally guarantees that if you follow this exact structure, you don't need to drop hundreds of dollars on paid courses to understand complex back-end architecture. It's a totally free roadmap, and we're going to dig into exactly what makes it so valuable today. So here is the exact game plan we're following today. First, the free masterclass roadmap. Second, requirements and APIs. Third, databases and speed. Then, queues and background jobs. Fifth, scaling for production. And finally, acing the design interview. All right, let's jump straight into part one, the free masterclass roadmap. Okay, get ready because we're looking at a massive summer of learning here. The whole foundation kicks off with a heavy 15 to 20-hour NodeJS masterclass at the end of June. Then, following right on its heels is a comprehensive NextJS course by the end of July. And the whole thing culminates in mid-August of 2026 with these huge, dedicated courses on agentic AI and the ultimate system design capstone. It is a really beautifully structured chronological path. Now take a look at this list. Notice what's kind of surprisingly absent. There's no Java, no Spring Boot, no ASP.NET. And actually, that is 100% intentional. This explainer zeroes in purely on the ecosystem Sangam knows inside and out. We're talking Node.js, Golang microservices, and Python for AI, all backed by Postgres and Redis. By sticking strictly to these, the actual code is pretty much pre-written for you. That is a game changer because it lets you focus entirely on the high-level system design concepts instead of getting bogged down in syntax errors. Moving right along to Section 2, Requirements and APIs. So the crucial concept to grasp here is this idea of responsibilities. Think of it like this. Whether you're building your app in Python, Node.js, or Golang, sure, the syntax changes, but the core responsibilities, they really don't. Universal requirements, things like authentication and role-based access control, they're always mandatory. You absolutely have to understand how different actors, like a normal user versus an admin versus a background worker, interact with your system. Basically, think of this API layer as your system's bouncer. Before a user even gets near your database, CDNs and DNS are out there routing their global traffic. Then, an API gateway steps up to manage their entry. This is where you'll be designing routes, strictly separating those public read REST APIs from your highly sensitive admin endpoints. And of course, you've got to implement rate limits so a random malicious script doesn't accidentally or intentionally set your servers on fire.
Let's dive deeper with Section 3, Databases and Speed.
Look, when we talk about databases at this scale, we aren't just slapping together some simple spreadsheets. You have to define really strict concurrency models. I mean, how do you map a complex flow, like someone confirming a purchase, directly to a database table without accidentally double charging them? You have to establish an ironclad single source of truth. And that comes down to sweating the nitty-gritty details, like setting up a Postgres connection ping between your API server and the database to ensure everything is actually talking properly. But here's the catch. A database on its own, it's just not fast enough for a modern application. Enter the speed layer. We bring in Redis for rapid retrieval using cache-aside patterns. But a word of warning here. Turning caching on is the easy part. Data invalidation, that's the real headache. You need strict, unbreakable rules to identify what's perfectly safe to cache, like a public list of blog posts, versus highly sensitive user data that should absolutely never, ever touch your cache layer. All right, on to Section 4, Queues and Background Jobs. Have you ever wondered why, when you buy something online, the app doesn't just freeze for 10 seconds while it tries to send you a confirmation email? That magic is all thanks to message queues. By leveraging queues, worker processes, and retries, we can take those slow, clunky tasks and shift them entirely off the main API request path. You'll get deep into techniques like the Outbox pattern. This is an awesome strategy that safely publishes events to background jobs, so literally zero critical data gets lost while you're waiting on some slow external processor to do its thing. Which brings us to the really fun stuff in Section 5, Scaling for Production. This is where we transition from a basic single server setup to a battle-ready intermediate architecture. If you want to survive a massive spike in traffic, your APIs have to become stateless. No exceptions. You're going to need load balancers to distribute that crazy traffic across multiple instances, database replicas so your system can handle heavy read workloads without lagging, and dedicated object storage so you can get massive file and video uploads the heck off your main servers. Because let's be real for a second. Scaling isn't just about handling more users, it's about surviving when things inevitably break. A beautifully designed system is entirely useless if it completely crashes during a big launch event. What actually happens if your payment provider drops mid-transaction, or if your Redis cache just dies? You're going to learn how to mitigate those database overloads and, crucially, establish the real-time audit logs and metrics you need so you can spot a catastrophic failure coming way before it takes you offline. Finally, let's wrap things up with Section 6, acing the design interview. When you're sitting in the hot seat, interviewers care most about your thinking process. They want to see how you evaluate trade-offs. For example, why would you choose pagination instead of infinite scroll? Well, if you just throw out buzzwords without explaining that pagination is way better for specific dashboard searches, while infinite scroll is custom-tailored for seamless social feed engagement, you probably won't pass. This curriculum gets you ready to confidently defend those exact kinds of design choices. By walking through these 3 specific steps, you seamlessly bridge that tricky gap between high-level architecture and low-level code implementation. First, you define the product expectations. Second, you lay out your high-level design trade-offs. And third, you trace the exact path of an API request, from the moment the client clicks all the way down to the database and back again. When your core concepts are this clear, your engineering mindset is just going to naturally shine through to the interviewer. So what's the big takeaway here? By having the code effectively pre-written for you, this masterclass completely strips away the syntax barrier. It frees your brain up to just purely focus on the engineering logic. With the coding portion out of the way and this incredible architectural blueprint laid out right in front of you, the only real question left is, how are you going to architect your next massive system? Thanks so much for joining me on this explainer, and I'll catch you next time.